And last but definitely not least in this mini is Rachel's talk. And we'll have fun with, I think, graphs and names.
That's about right. Oh, is that? Oh, maybe. Uh,
It came back.
okay. All right, press on. Yes, okay, so this is actually a project, as I'll explain in a second, from probably like 4 years ago at this point. But when I saw there was a recreational mini this JuliaCon, I was inspired to finally talk about it a little bit. So to set this up, I need a little bit of context. Probably many people, I would wager to guess everyone in this room is familiar with both of the two crucial pieces of context I'm about to provide. One is the concept of nerd sniping. This is at least the second XKCD reference in this mini symposium, which I consider a success. So I'll leave it up there if you want. If you feel like reading the whole thing, it's a classic XKCD comic. The notion is that basically a certain kind of nerd is very easily incapacitated by interesting intellectual problems. Second piece of context, COVID-19. We are probably all sadly familiar with this. We were cooped up inside for a while. We had a lot of time on our hands. This, I would argue, created a particular vulnerability to being nerd sniped. I also had a partner who is now my spouse who is very good at inadvertently nerd sniping me with fun questions. And to be very clear, I love him for this. So you probably see where this is going. I estimate this was like mid-2021 sometime. We're still very much working from home, sitting on a couch in the living room. And Jerry, who you might guess from this is a fluid dynamicist, goes, Plateau Rayleigh, Rayleigh Taylor, Taylor Couette. I wonder what the longest chain you could make like this is from theories that are named after hyphenated combinations of people. So I, who had been doing some things involving graphs for my work at the time, immediately thought this is clearly a job for directed graphs. We should build a really big directed graph and do this analysis. Okay, so let's look at it. So there is a package. It is not registered. It's not letting me switch my window. Okay, maybe I have to leave the presentation. Let's do that. Fun. Okay, so we can load this stuff up. No, you don't. No, please don't do that. Hello. No, no, stop. Uh-oh. Okay. All right, so we can load in some packages, get those going. Let's pick a number. I'm just going to go with the first one that I picked. This is on a branch of the repository that I'll pull up in a second. So if you want to try with some different ones, I have some suggestions of ones that I think would be fun here. Okay, so all that Nodariety really does is it creates there's some functions as well, but it creates this big thing called a variable called HG for hyphen graph. This hyphen graph has 446 people and 383 hyphens in it. It's a big directed graph representing a bunch of different theories. We can look at things like the properties of the node for the value of n that I chose, which is just Paul Dirac, weird little dude, pretty smart. We can do graphy things to it. So what are some in neighbors? What are some out neighbors? So who is Dirac hyphenated to and from? Let's look at one of those in neighbors. We can find some information about the edge too. This leverages the nice metagraphs package. So this happens to relate to Fermi-Dirac statistics, something I think about a lot in my actual work. So this hyphen has to do with, is the hyphenation between Enrico Fermi and Paul Dirac. Excellent. Okay, but let's answer the original question. So what's the longest path? There's a longest paths package that builds on the great graphs.jl interface. So we can answer that question. That thing takes just a second to run, especially on this old laptop. There's an issue open in the repository. This package doesn't currently run on M series Macs because it relies on a package that doesn't support M series. If anyone wants to fix that, please feel free. But for now, I'm using my 10-year-old laptop. Okay, so what is the actual list of names? We can pull the subgraph corresponding to that. So this is now, and then just pull out the names of people from that. So Navier-Stokes, Stokes-Einstein, Einstein-Cartan, you get the idea. That's one option. There's a different one that starts with somebody else before Stokes, and it's otherwise the same path. We can, of course, thanks to the power of multiple dispatch and interfaces and all these lovely things, ask about other things like various measures of graph centrality. So I wrote a little helper function to just call all of the centrality measures that are built into graphs.jl. So you'll see some familiar names here that show up that tend to get hyphenated with a lot of different people. The eigenvalue one takes a long time to run. It also doesn't give you the same answer every time because that's how that algorithm works. Oh, we got bows this time. Fun. Okay. We can look at cycles. That's sort of fun too. There's actually only one cycle. Directed graph cycles, obviously, a little bit harder to find. So who are the three? Oh no, what did I do? All right, we're going to skip ahead because I have 4 minutes left and I don't know what happened. There's some really depressing demographic plots you can make in here. I'll do the least depressing one, which is still kind of depressing, which is birth country of everyone that's represented in this. Of course, this is somewhat biased by my particular data collection technique, which involved just clicking through a bunch of link trees on Wikipedia. But unsurprisingly, you see kind of the usual suspects exceptionally overrepresented here. The same thing holds true for gender and all sorts of other demographic things you could look at. There's some visualization stuff built in that makes use of GraphMocky. So I'll just pull, just to make this a little bit cleaner, I'll just pull the biggest cluster here so we can get the induced subgraph from that cluster. The biggest cluster has 168 people and 178 hyphens, so we can plot that with GraphMocky. This is like kind of a mess. I'm coloring it right now. You can color it by different things, which is sort of fun. So it's colored by, the nodes are colored by the birth year of the individual, and the edges are colored by the year of that the theory was first published. So you can see interesting things happen, like there's cases where a color of a node is very different from an edge, like a theory was put forth like way after somebody was born, which is kind of fun. We can like zoom in around on this thing. It's being really slow, of course. But anyway, you see some people represented here. The graph layouts are hard, right? Like this was the best one of the built-in ones I could find. It's still pretty bad, but that's okay. And then, so because I wasn't really happy with that graph layout, I also grabbed this other, this is JavaScript, unfortunately, but it's slightly better visualizer. So this is actually the whole graph, and you can do fun things here, like click on individual people. So there's Hilbert and a bunch of guys that Hilbert is hyphenated to. You can click around and kind of keep traversing this way, which is sort of fun. And it gives you some little bits of information about these people too. Gauss has a lot of edges. Gauss always seems to come first. That's another interesting one you find. Like Gauss comes first in these hyphenated things. Legendre. So yeah, that's kind of fun. And with my last couple of minutes, I'll jump back here and say just a couple more words. Is that back up? Yes, excellent. Okay, so some reflections on why this was fun. Tedious data collation is my love language. You can obviously imagine here that the vast majority of time putting this together was actually sourcing the data. Because of all the graphs ecosystem stuff in Julia, the actual building of the thing was like pretty trivial but getting the data together to have something interesting to look at took the vast majority of the time. I got to skim a lot of Wikipedia pages. That was kind of fun. Julian interfaces and multiple dispatches, I already alluded to, made all the graph analysis stuff come like basically for free. You dispatch like 10 functions on your new graph type, and then the whole thing just like does its magic. So you don't really have to do anything yourself. Okay, and then if there is any time, I'm happy to take questions. I'm happy to take PRs. We could register it. It's not currently registered. There are some issues with suggestions if you feel like implementing anything. One of them is just entitled erdish ... because I didn't have the courage to go down that rabbit hole, but if anyone felt like it, you could. And yeah, if there's any time for questions, I'm very happy to take them. Thank you.
There is time for questions. Thanks. Do we have questions from the audience? It does not look like. So I'm really much interested in how you did the data collection.
It was systematic in some ways and extremely unsystematic in others. So it started just sort of off the top of my head. I have primarily a physics education. Obviously, somewhat of a math education comes along with that. And so starting by just thinking of all the things that I could think of and then kind of chasing tails on Wikipedia by looking up both people on either end of a hyphen and seeing, they always have that little convenient, like, known for the blah-de-blah theorem, the blah-de-blah postulate, whatever. And so just kind of like following all of those trails was basically the process that I took. So it definitely preferences a more connected graph, I would say, because it would seed off of something that I thought of, and then I just kind of continue chasing tails. So there are disconnected like dyads in there, but not a huge number of them.
But could we try to, so I think Wikipedia is also known for having lists articles, right? And there should be like lists of famous mathematicians,
Yeah.
physicists, chemists, and
Yep.
could we systematically parse that as well?
Oh, probably. Yeah.
Okay.
Would take a while.
And the other thing is, so there's also this badge on GitHub that you get when you have a pull request where two programmers contributed to.
Oh.
So that seems like something where we could apply this to GitHub data.
Yeah. Oh, that's an interesting. Yeah, interesting. Yeah, and I mean, of course, the other level you could go to with all of this would be like go to hypergraphs, right? Like there are plenty of things named after more than two people. I sort of deliberately limited this to just like whatever the word for non-hypergraph is that I'm blanking on at the moment because there's a bright light in my face. But yeah, so you could go beyond that too. Yeah.
Thank you. This is a lot of fun. I was wondering, I guess this comes from ignorance maybe, but is there a convention of who goes first in like
So
first,
yeah, that's
etc.?
interesting because like usually yes. I mean, there's not a convention in the sense of like a rule to predict it, but there is for the vast majority of these things. There is like it's usually called Navier-Stokes. People don't call it Stokes-Navier for whatever reason. There are a few instances of cases where you see it both ways, but that's surprisingly uncommon. There's usually just like something that kind of takes hold, and that's what people call it.
And I guess this is a little bit following question on that is like I wonder if the ordering influences anything regarding users citations, like popularity of it.
Yeah, it's interesting. I mean, it obviously influences some of these graph properties because it's encoded as a directed graph, and so the sort of directionality of the edges impacts the way that various algorithms compute things like centrality and how you can traverse it and all that good stuff. In terms of the sort of citation dynamics and all of that sort of stuff, I don't know. That's an interesting question.
All right. Do we have more questions? If not, then let's thank Rachel again.